The other type of the scale, the leftover is a Vernier scale. So what is a Vernier? So generally whatever the instrument you are used in your earlier classes, the same principle we are used in the construction. So what the difference mean in the physical Vernier scale, main scale as well as a Vernier scale. So onto the one to the other there is a movable. But on the chart we cannot take that construction, but only that represent the principle what we are using there, the same principle we are using in the Vernier scale construction also. So first let me discuss the principle, then we will discuss the problems. So Vernier scale. So one main scale will be there. Main scale is same as a plane scale construction. How we did the beginning of the scales problem we discussed. The same similar the plane scale has to be constructed. So what we divided depends on the maximum length. We are supposed to divide the main scale into the number of divisions. So let me divide the 4 divisions. So we are taking the left. In the plane scale directly we are making the divisions. The same similar manner, suppose it is a decimal system, we may divide into the 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what the change? This is the main scale we are saying. This Vernier depends on how the number of divisions we are considering. We may consider the n number of divisions 1 less, so then it is known as the forward Vernier. If you consider 1 division more, so that comes under the backward Vernier. Other names for the forward Vernier is the direct Vernier. Other name for the backward Vernier is the retrograde Vernier. So one coming to how the Vernier to be constructed here. Suppose let me consider the forward Vernier. So number of divisions need to be considered is the n minus 1. We have taken already n divisions are the 10. So minus 1 means the 9 divisions. But length of the Vernier to be 9 divisions. But number of divisions should be considered same as the number of divisions we did in the main scale. So being here 10 divisions we did, the same 10 divisions supposed to divide here also. So then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, the same thing for relatively how the difference you are find for the retrograde Vernier. So further what the difference from the forward to retrograde, only the number of divisions what we are considered for a Vernier length. Being here we are taken as a minus 1, when you are considering for the retrograde Vernier plus 1 division so to take. So on the same scale I am considering, but whenever discuss the problems we will need separately, but as a comparison of all the difference. Here we are considered 1 less as compared to the number of divisions. Whenever the retrograde Vernier, already you divided it so that you can get each division measurement you known. So same measured length of 1 division to be extended. Now consider this as a Vernier length. Vernier consider plus 1 you are taking division, we are constructing the Vernier length by considering the plus 1 value. So that comes under the construction of retrograde or known as a backward Vernier. But number of divisions coming to here, the same number of divisions we have to did. So what we did in the main scale, one of the rectangular part. So being the n number is 10, so we will divide here also 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there is the difference. So whenever any problem given, particularly ask any method of the construction of Vernier, you have to do by that method only. But whenever not given, the choice is ours. Either we can consider forward Vernier or backward Vernier. What the difference forward Vernier? Only Vernier length only changes. Vernier length here n minus 1, in other n plus 1. So let me check by discussing the Vernier scale. One of the problem, just I read out, listen. Construct a Vernier with a scale of 1:40 and long enough to measure up to 6 meters. Show 4.76 meters on it. So just you can observe here, after the decimal fraction, the 2 digits you are asking mean you have to consider either the diagonal or Vernier. But here the particularly asking the construct to be Vernier scale, so we have to consider the Vernier. But here the method is not mentioned whether forward Vernier or backward Vernier. The same problem we'll check first forward Vernier how to be constructed. So next later we check by the other method backward, that is the retrograde method. So as a sequence we are discussed in the earlier problems. So what the any scale construction, the starts from calculation of RF. So already we did in the so many problems. So RF calculation how we did? RF is nothing but representation factor. So which gives the ratio between drawing length by object length. So you need not to calculate why, because in this problem directly given. Whenever not given, you have to consider observe the drawing length as well as the object length. So take the ratio so that you get in the represented factor. Here the mentioned straight away 1:40. So that can be written as 1/40 as RF. So next second step, what we did in the earlier cases, we have found the length of the scale. That is the compulsory. So then only I can draw that particular length calculated. So LS, length of the scale, how it will be calculated? RF multiplied by maximum length to be measured. So in this also you can observe here, RF already we are considered as a 1/40. Maximum length to be considered. What is the maximum length? It is given in the problem. Long enough to measure up to 6 meters. So 6 meters is the longest distance I required. So simply multiply with 6 meters. But one more thing you have to recognize, same as the earlier cases we did, meters cannot be represented directly, so that convenient we are using the centimeters. So convert back up to the centimeters. So 1 meter equals to 100 centimeters. So multiply with 100 so that I can get into the in terms of centimeters. So now simplify so that I can get the value. 1 0 get cancelled. 4 mean 1.5. How much are you getting? 15 centimeters. So once I calculated RF and LS, so the next step is the construction. The calculated LS you are getting is a 15 centimeters. So draw 15 centimeters, same as the plane scale. Just now before beginning of the Vernier also we discussed, it should be the main scale to be drawn same as we did in the case of that means the LS calculated 15 centimeter, width of 1 centimeter and complete a rectangle so that it resembles a scale looks. So after that, how many parts it has to be divided? The same earlier so many problems we did, you have to focus on maximum length given. Maximum length given in this problem is 6 meters, so that it has to be decided to divide into the 6 equal number of divisions. So 15/6 again we are getting as a irregular fraction value. So whenever getting the irregular fraction value, so please apply the method of geometrical construction division. So what is that? You have to just take assistance of the line, any convenient length with any angle, and even the 6 parts, how many we required in this case? 6 equal divisions. So just offset 6 equal divisions, 1, 2, 3, 4, 5, 6. The 6th one has to be joined with the end of the line. 6th division should be joined with the end line. So next, parallel to this line, from every point we have to draw the lines. Parallel to that one, we have to draw the from every line, so that where it meets the on the line, those points will be exactly divisible points. Okay. So now what the points are getting, from there draw the vertical line so that it represents the divisible portions. The same thing, the first one you have to leave, mark it as a 0, thereafter 1, 2, 3, 4, 5. Please don't forget to write what are the units of measure, being we are considering for the meter, write the meter. Same as the plane scale, the left rectangle block has to be subdivided into the required sublevel components. How many parts it has to be subdivided? Again 10 divisions. Being the decimal system, the required the low level divisions are sum of the 10 divisions. So again divide into the 10 divisions. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 10. Now label every point value. How much each point value? We have taken the 1 unit and divided into the 10 equal divisions. 1 by 10. Each value you are getting as the 0.1. So let is the 0.1. The second division I can directly write 0.2, 0.3, 0.4, 0.5, 0.6, 0.8 and so now you have to choose in for, there is a 2 types of the vernier just as we discussed. So let me check by considering the forward vernier. So for the forward vernier, what I need, forward vernier, we have to consider vernier length. So what the vernier length to be considered, just as we discussed, n minus 1. We divided into the n as a 10 numbers. So n minus 1 means 9 divisions to be considered as the length of the scale. Just I am taking 1 less as compared to the 10 divisions, and just try to reconstruct a vernier. This is the vernier. But on this vernier, how many divisions you have to do? There is no, even it is the equivalent to the 9 divisions, but you have to divide same as the n number of divisions. We are chosen n as a 10. Here also no alternate, you have to divide 10 divisions only. So let us divide the 10 equal divisions. So 1, 2, 3, 4, 5, 6, 7, 8. Please ensure that I am just only explaining here the methodology what you have to do. But by using the proper instrument, you have to division, you have to check that every interval should be get same equal length. So that is a good drawing, then only you can get the full marks. So now coming to the write the values here. So before just write the values, so let one little calculation you have to proceed here. Now this is a main scale, we are saying it is a main scale. So what is the each division of the main scale? What is the minimum division value of the main scale division? So that can be written as 1 MSD. MSD is nothing but 1 main scale division. So this we are saying that each block has a 1 meter. We divide into the 10 equal divisions. So what is the value of 1 division? 1 by 10. So that is equals to 0.1 meter. Next you have to calculate value of 1 VSD. VSD mean Vernier scale division. MSD mean main scale division. Main scale division, the main scale, the each division of the main scale division value as 0.1 meter. Similarly, you have to find what is the value of 1 division on the Vernier scale. So that can be written as 1 VSD. It is nothing but Vernier scale division. How it can be calculated? We have taken length by number of division. You are getting as a equal value. So length 1 we are taken as a length, number of divisions 10, so that I am getting the 0.1. Similarly, in the calculation of VSD also, we have to consider the length of the vernier by number of divisions. So then you can find each value of the 1 division. So let's calculate here what the value can get here. What is the length can consider? I am taking the length equals to 9 division, but that is the n minus 1 divisions I took for forward vernier. So 10 minus 1 how much? 9 into each division value how much I taken? 0.1 divided by number of divisions. How many divisions we need here? 10. So I can take. So 9 into 0.1 is you are getting as 0.9. 0.9 divided by 10 is 0.09 meters. 0.09 meters. Similarly, sometimes in the problems you may ask least count. The least count is meant the lowest value can be measured by that instrument, that is the least count. So what is the least count of the vernier? So I can say the least count here. Least count of the vernier 1 MSD minus 1 VSD. I can say instead of the minus difference also I can show. What is the difference between the 1 main scale division value and the 1 vernier scale division? So straight away I can calculate. That is a 0.1 minus 0.09. How much you are getting? 0.01 meter. So this is the least count of the instrument. 0.01 meter is the least count. Please once again just listen here. 1 MSD mean 1 main scale division. So that equivalent to 1 unit of measured scale divided by number of divisions. So in this case we are taking the 1 meter, we are dividing the 10, we are getting 0.1. Similarly, vernier scale 1 division to be calculated. VSD mean vernier scale division. So for that length by number of divisions, length is equivalent to the 9 divisions. So 9 into 0.1 divided by number of divisions of 10, you are getting 0.09. Similarly, you have to please appropriate. Please mention the least count of the instrument also. Least count can be calculated as the difference of 1 MSD to 1 VSD. So just we are taking the value of 1 MSD to 1 VSD. We are getting least count of the value 0.01 meter. Please don't confuse while writing the values here. So what are the values to be written based on the value of each 1 VSD. How we are taken here 0.1, 0.2, 0.3 on MSD. You have to mention the values on here by considering the one value of VSD. What is the one value of the VSD? 0.09 meters. So being it is closely attached to 0, the first division value is 0 only. So where is the second division? Here to here, what is the length you can see? One value as 0.09. So I can write here as a 0.09 meters. Next, similarly, the second one plus you are adding 0.09, so that you can consider as a 0.09 plus 0.09, so that we can get as a 0.18. Next, adding the third one 0.27, the fourth one. So like that I can number here each division, why? Because we are not accumulate here. I write the each division value here. The first division value 0.09, second division value plus 0.9 mean 0.18, the third division value plus 0.9 0.27, fourth one 0.36, fifth one 0.45, sixth one 0.54, seventh one 0.63, eighth one 0.72, ninth one 0.81, 10th one is 0.9. The total length equals nothing but 9 divisions into 0.1 is 0.9, so that we reach the Vernier length. So this is the division value. The last division value I get 0.9. So now to mention the required length. What the length is asking, this is the construction. Regarding the construction of forward Vernier, this is the method. First we have to draw the same as the plane scale after calculating RF and LS. After that you divide this as the same similar plane scale what we discussed in the earlier problems. After that extra thing we have to add the Vernier on this one. Vernier considering the Vernier, there is the two possibilities. There is a forward Vernier or backward Vernier. When you have to construct the forward Vernier, I have to consider the Vernier length as n minus 1. So that's why I taken the 1 less as compared to the number of divisions and drawn a Vernier length. After that it has to be divided the same number of n division, that is the 10 in this case. After that you have to find the each division value by taking the support calculation. 1 MSD equal to 0.1 mm, 0.1 meter. 1 VSD, Vernier scale division, equals to 0.09 meters. Least count is difference of the MSD and VSD 0.01. After writing this one, please try to write every line value in this one clearly. So each line value after writing this one 0.0818, after that 0.27, next 0.36, so like that. Elaborately whatever discussed we are not getting, even writing you are not able to view, so that's why I just clearly given what is the each value of division value. So 1 to 10 you are getting as up to 0.9. So next you have to marking. This is the construction part. Next the problem solution, you have to support what has been given to mark. What has been given? Show a distance. How much? 4.76 meters on it. So earlier all the cases either the plane scale or comparative scale or diagonal scale, what we did? We are first identify the extension line at the right side, then you are coming to the on the left floatable scale. So being in the previous cases, so directly they can take it as a 1, 2, 3, 4 in this order. So that's why the flexibility is there. I can come from here to here. But as you can observe here, so what the values you are having 9, 8, and so like that, it is not in the same order as a 1, 2, 3, 4 like that one. It is in the decreasing order, so that I cannot come here to here to identify the directly correct position. So that I have to first identify the dimension on the Vernier, then remaining dimension to me I have to focus on the main scale division. So now in this case, what the distance I have to suppose to mark 4.76 meters I have to mark. 4.76 meters I have to mark. So what the thing you have to keep in mind means, I have to consider the end digit value where it matches. Suppose in this one, in which division end digit value matches? The 6 is the end digit value here. Here is the 9 first division. Second division we are having the 8. Third division I am having 7. Fourth division I am having the 6. That means 1, 2, 3, 4th. This fourth line to be considered. Fourth line when you are considering here to here, what the distance I am covering? 0.36 I am covering. So subtract the dimension. 0.36. 0, 7 minus 3 is 4. 4.4 we are having. So then remaining length. On the Vernier I covered 0.36 value of the dimension covered. The remaining 4.40 has to be extended to the right side on the main scale. So 4.40 means 1, 2, 3, 4. Up to the 4 I am getting as a 4. After latter stage, how much I required? 0.4 is required. So that in this region again I have to subdivide into the 10 equal number divisions. So then only I can identify the 0.4. So let us subdivide it again here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what is each decision value? This is a 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. That means 1, 2, 3. Fourth division I can consider because I required 4.40 is the required value. So I have to take exactly at the fourth line as my reference. This one. Now show the dimension. What is maximum distance? 4.76 meters. So I can write 4.76 meters. So you have to please mention in the brackets how we are attaining that one. So I am attained on the vernier length 0.36. The remaining length of 4.40 I consider on a main scale. This is the procedure. After that you have to show the total length as well as RF calculation also. So this completes the construction of the vernier, how to be constructed. So what we discuss in this case, we discuss how to construct a vernier scale by the method of forward vernier or direct vernier. So let's check the same problem by the other method, backward or retrograde. Okay, backward vernier or retrograde vernier. So for the same, so what are calculated? RF we are calculated. So how much we are getting? 1 by 40 straight away given. The LS for particular length we are getting as a 15 centimeter. The same thing you have to consider here. So draw here 15 centimeters of the length, 1 centimeter width. It has to be subdivided by the same method applying. So directly you can just check on your practice, but you have to apply the geometrical division method. So I have to divide into the 10, 6 meters representing means 6 divisions. 1, 2, 3, 4, 5, 6. Okay. 0, 1, 2, 3, 4, 5. What are the units? Being it is the meters, write the meters. After that, what you have to do? You have to left extreme rectangle subdivide into the 10 divisions. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So write the each digit value. 0.1, this is 0.2, 0.4, 0.5, 0.6, 0.8, 1. These also units in meters only. This is up to the same as the plane scale what we constructed. So next change you have to construct the vernier. How the vernier to be constructed? So for the construction of the vernier, I have to construct the retrograde vernier. In the retrograde vernier, vernier length should be n plus 1. These are the n number of divisions available. I have to consider the n plus 1. N plus 1 means one value of the division extra you have to find. You know that each interval of the division, measure that one and whatever the equal length you have to extra you have to take. Then take the same width of 1 centimeter. Clear? I construct what the difference from the previous two. In the previous one, what the change you are getting here? The 1 minus you are taking, the less part I am taking, but here one extra part you are taking. So that's why in the forward vernier, the VL, that is the vernier length is n minus 1. In this case, vernier length is n minus 1. Whereas in this case, vernier length is a n plus 1. That only the difference, the remaining things are same. It has to be subdivided into the n, how many numbers? Same as the n, being your division into the 10 equal parts, it has to be divided into the 10 equal parts. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Being the 0 coincide, the part length is 0. So thereafter try to calculate the same as earlier. 1 MSD equals to, that means 1 main scale division equals to how much? 1 meter. This is the 1 meter divided by 10. So you are getting a 0.1 meter. Similarly, I have to calculate one value of division in VSD. So 1 VSD equals to Vernier length by 10. So what is the Vernier length I am taking? Equivalent to the length divisions. Equivalent to the 11 divisions. So 11 divisions multiplied by each value of division. How much each value taking? 0.1 divided by 10. How much are you getting? 1.1 divided by 10. So I am getting 0.11. 0.11 meters. So now least count you have to find. How will you find the least count? Just I explain. It is the difference of 1 MSD, difference of 1 VSD. So what the difference I can write here? 0.1 difference of 0.11. So what the difference you are getting? Again it is a 0.01 meters. Is there any change in the previous case to this case? Is there any change here? The least count I am getting 0.01 meters. In this case also I am getting the 0.01 meter. So there is no change in the precision value you are getting, but only the change there is a methodology. The methodology only different in this case. So now once you are getting as a value of 1 VSD, please try to establish values of in each case. So how much value of the each division VSD? One Vernier scale division is equal to 0.11. So this is a 0. From the first division what could be? 0.11 meter. So what the second division? 0.22. Third division is 0.33. Fourth division is 0.44. Fifth one is 0.55. Sixth one is 0.66. Seventh one is 0.77. Eighth one is 0.88. Ninth one is 0.99. Last one is 1.1. Clear? So now once identifying the values, then you have to, this is the construction part. Construction part of the Vernier completed. Then you have to show what is the value to be supposed to show on the Vernier. So in this problem, what has been given? 4.76 meters. Up to 6 meter and show 4.76 meters on it. So what are the dimension I have to mark? 4.76 to be marked. So right aside 4.76 meters. So just now in the previous case I explained what the difficulty you are having. I cannot float from here to here. So why? Because in this order, not in the same order. Compulsory you have to move from here to here. So that's why you have to match the digit value. What the digit value getting? 6. So where you are getting the 6? Here is the 1, 2, 3, 4, 5, 6. Sixth digit value I am getting here. So mark here first extension line. On the Vernier length, this much length covered. This much length means 0.66 already covered. So subtract that one, 0.66. So what the leftover? 0, 1, 4.10. We are having the 4.10. So the leftover distance has to be marked here. So 1, 2, 3, 4 you are getting. So where they are getting the fourth one? In the subdivisions I need. So wherever the required extra thing, you have to make again subdivision on that particular portion only. You need not to divide every block into the 10. Okay. So why I need? After the 4 I want to identify the one division. So that's why you have to divide into the again 10 equal divisions. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each value is 0.1, 0.2, 0.3, 0.4, 0.5. So like that I can identify. So now coming to the marking of the distance. How the distance can be marked here? The first extension line I have taken here. 0.66 already covered on the Vernier length. So I am subtracting. The leftover distance is 4.10. So here also I have to take the distance of 4.10. So 1, 2, 3, 4. After the 4 I have to take the first division. So I am getting the 4.1 and draw the extension line. Now write the value. How much total length now? 4.76 meters. So how we are getting? So how we are attained also, please better to just mention in the brackets how it is attaining. On the Vernier I am getting as a 0.66 plus on the main scale 1, 2, 3, 4.1. So 4.1 meters I am getting. By sum of the distances, I can conclude whatever the total distance you are getting. Okay. So that is the difference of the construction compared to the forward vernier to the backward vernier. In the retrograde vernier or backward vernier, what the difference? The vernier length we are considering the one division extra, n plus 1. But length we may take n plus 1, but number of division we are doing n divisions only. Where n is nothing but number of division we did in the main scale, the one division, subdivisions. So 10 we are divided, so 10 you have to divide. After that, calculation part is more important in the vernier scales. Calculate 1 MSD, 1 VSD. After that, even not asking, please try to present the least count for us also. The least count when calculated, difference of main scale division to vernier scale division. Don't write this as a minus 0.01. So that's why I am using the symbol difference mean the differences is always the positive values only. So write positive value as the 0.01 meter. So once you identify the vernier scale division value, so write all the digit values. So next, what the dimension to be marked? Check end digit where it is matching, that division is take the first extension line. From that, how much distance you are taken on the vernier that to be subtracted, the remaining length has to be moved along the vernier scale. Where you need subdivision in that particular region, please make once again subdivision and just identify leftover distance on the main scale. So by adding the vernier scale length and what are the distance on the main scale division, you are able to represent the total distance required as per the problem requirement. So this is about a problem of the vernier. Just I am reading the problem. Just try to understand the problem what has been given. On a map, a rectangle of 125 centimeter and 200 centimeter represents an area of 6,250 square kilometers. Construct a vernier long enough to measure up to 7 kilometers. Mark a length of 5.43 kilometers on it. So what the problem has been given here? The same vernier has to be constructed here. So being the after the decimal fraction we need the 2-digit value, so that we need vernier construction. So whenever the vernier construction, what the construction may be, it little different, but calculation part is the same as the earlier discussion. Just now we checked one problem, the same similar line of calculation you have to carry forward here also. The first step, you have to start in our scale construction with calculation of RF, representation factor. Drawing length by object length. So what the drawing length we are considering here and object length considering. It little bit logically mentioned here. So drawing length considered here. On a map means on a particular drawing he is giving a rectangle is what the thing is represented in terms of a rectangle with the given sides of 125 centimeters into 200 centimeters. When you are multiplying side into side is nothing but area of a rectangle. So the same length into breadth is the given. You have to take same what has been given here. 125 multiplied by 200. Both are the units are in centimeter. This is in centimeter. This also in centimeter. Divided by object length. So what the object length has given? 6250. 6250. So what the units given? Is a square kilometer. Square kilometer mean kilometer square given. So now the value to be calculated. So how the value calculated you are getting? This is the length and breadth given. It is directly area given. By giving the length into breadth also you are getting same as the area. So 125 into 200 you are getting the value as 2500. Centimeter into centimeter, square centimeter, divided by 6250 square kilometer. So already previous problems in the some cases we discussed this relation. Already we have to keep in mind. So what we have suggested, whenever the scale you are using, it is a linear function. That means linear measurements only to consider. But what has a logically given here? It is in area mean length into length. Again is also area into length into length. L square getting. But we need not required in L square. You have to just make it to bring down in the L. So how will bring L? So if you apply the square root, L square root is nothing but getting the L. So numerator, denominator, both are we are having the in terms of L square. So that commonly you can apply a square root. So when applying the square root, so that I can simplify. So how to simplify again? By calculations, you may get it is by end value of 2 by 10 to the power of 5. That becomes, if we are calculating, 1 by 50,000. So I can just writing RF value only directly. RF I can get, so 2 by 10 to the power of 1, it gets us only getting in the 5. After 5, 4 zeros. After 5, 4 zeros, we are getting 50,000. So RF I can write 1 by 50,000. LS to be calculated. How the LS to be calculated? For LS calculation, please remain once again the relation you will keep in mind. RF multiplied by maximum length to be measured. So what the RF is given in this case? 1 by 50,000. Just now you are calculated. Maximum length, you have to read the problem. So what the maximum length has been given? Construct a vernier long enough to measure up to 7 kilometers. So maximum length is given in this problem is a 7 kilometers you have to consider. So let I am considering the 7 kilometer is not feasible to represent in our drawing. So better to convenient scale is a centimeter. So bring down the units until getting the centimeters. So 1 kilometer I can write as a 1000 meters. So I am multiplying. Meter again is the problem, so let multiply with the 100, so that 1 meter equals 100 centimeter. So I am multiplying. So now I simplify. The 3 zeros get cancelled. 51s are, 52s are. So what the leftover distance is, you are getting LS as 2 into 7, 14 centimeters negative. So once you are getting the LS, so then the term comes into representation of the values. So once you are getting the R equal to LS, the third is the construction part. The third construction part is the vernier. You have to construct the main scale. Over the main scale, you have to construct the vernier scale. So by taking the length of 14 centimeters, same as the plane scale. How the plane scale we are constructing? The plane scale be constructed the same as taking the LS width to be considered 1s. After that, how many parts it has to be subdivided. For dividing the subdivision, please keep in mind always you have to focus maximum length to be measured. What the maximum length to be measured? 7 kilometers. Suppose you have to divide logically into the 7 equal parts, so that each part I can represent as a 1 unit, that is a 1 kilometer distance. So for that, 14 divided by 7, I am getting the 2 centimeters each. I am not getting any irregular fraction, so directly with the normal scale also you can proceed for the division. But where you are getting the irregular, try to apply the geometrical construction in the previous problem what we suggested like that one. So here directly you can proceed. So I am proceeding 1, 2, 3, 4, 5, 6. Okay. On the paper you may not getting, but you have to try to ensure that each division must you are getting as a equivalence only. So after the first part label as a 0, thereafter 1, 2, 3, 4, 5, 6. Write the units here. For the units we are using kilometers, the same unit you have to write kilometer. After that, here the choice of the vernier scale. When you want to construct the vernier scale, so there is a possibility of alternate. Whether I can apply forward vernier or backward vernier, so that is the wish. In the previous problem, you might be understood both the methods how to construct the forward vernier or retrograde vernier. Only the difference by considering the length only differentiate from method one to the other method. The remaining everything calculation part is the same as both methods same. So now consider, let me divide the forward vernier. In the forward vernier, when you are considering the forward vernier, so vernier length to be calculated first. So what the vernier length? VL equals to N minus 1. Okay, N minus 1 means this main scale, whatever the floating division, how many divisions you are going to do, so that less 1 as to consider the minus 1. So being the decimal system, as it is a unit of the one distance, so there is a 1 kilometer, the probably you have to depend on the 10 divisions only. So let them divide the 10 equal divisions. as a 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is each division value? This total distance is represented in the 1 kilometer. So we are dividing the 10 equal divisions, mean 1 by 10 you are getting as a 0.1. So let I writing the 0.1, 0.2, 0.3, 0.4, 0.5, 6, 7, 8 and 9, and this is a 1 kilometer. Here also erasing the same units, that is the kilometers. After that, n minus 1 divisions. So being we are considering here as a n divisions has a 10, n minus 1 mean minus 10, 10 minus 1 mean 9. I am just leaving the 1 division from the left extreme and taking length of 1 centimeter. This is the vernier. But once the vernier length decided as a n minus 1, so that is I taking the 1 division less as compared to the 10 divisions and taking this 9 divisions length as same as the 1 centimeter width. I am just construct the vernier. In this vernier again you have to divide based on number of divisions only. In the number of divisions already we did in the 10, you have to divide compulsory 10 equal divisions once again. Let divide into the 10 divisions here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So after that, you have to write the respective values same as the previous case. So how to write the previous case? You have to just support calculation you have to give. 1 MSD equals to how much? 1 divided by 10. So that you are getting as a 0.1 kilometer. 1 VSD equals to number of vernier length. How much vernier length we consider? The 9 divisions. So 9 into value of each division 0.1 divided by 10, you are getting a 0.09 kilometer. Next, least count of the instrument, 1 MSD difference of 1 VSD, so that equals to 0.1 minus 0.09, you are getting a 0.01 kilometer. So then write the each value of by considering the VSD value. 0.09 means being it is matching with 0, this will be 0, this will be 0.09, this will be 0.18, 0.27, 0.36, 0.45, 0.54, 0.63, 0.72, 0.81 and 0.9. So once you are identifying, the leftover is the mark, distance to be marked. So what the distance to be marked? 5.43. So just 5.43, write somewhere here, kilometer to mark. Please check for the matching of the end digit value. Where the end digit value? 9, 8, 7, 6, 5, 4, 3. Here we are matching the end digit value. Just draw the extension line first at the 0.63. So in this vernier, from here to here, how much distance we are covering? 0.63. So subtract this one, 0.63 minus 14 minus 6, 8. Here is the 4.8. That means on the vernier you are able to measure 0.63. The leftover distance 4.8 to be covered on the main scale. 1, 2, 3, 4. So after this one, 1, 2, 3, 4. The after 4 we need 0.8. So again you have to subdivision into 10 equal divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 8th division to be considered. Next, how the logically you are attained also you have to mention. On the vernier scale we are covered 0.63 plus on the main scale I covered 4.80. So both adding I can just get the sum of the 5.43. So after that, to complete the solution I have to show the complete total length also. Total length is 7 kilometers.